So now we are in chapter 5.1 and we're going to be looking at the introduction to the normal distributions. Our objectives are to interpret graphs of the normal probability distribution and then find the areas under the standard normal curve. So let's start by talking about the continuous random variable. Remember that a continuous random variable, it has an infinite number of possible values that can be represented by an interval on the number line. And they gave us the example hours spent studying in a day. Because time, hours, is continuous, you would graph it using your number line. Remember, the opposite of continuous was discrete. Discrete means I can count it on my fingers, one at a time. The continuous random variable goes along with the continuous probability distribution. Now, here are some properties of your normal distribution. These are properties that are good to know, but you won't be required to know them. So the first one says that the mean, the median, and the mode are all equal. They're in the middle. So my normal distribution is represented by this curve, and down the middle represents my mean, my median, and mode. And then the second one says the normal curve is a bell shape and symmetric about the mean. So it's bell shape, and symmetric means that if I draw a dashed line down, the left half looks exactly like the right half. And then the third one says the total area under the curve is equal to 1. So if I add up the entire area, that will give us 1. Area is the same as saying probability. So remember that all probabilities sum to 1. And then the last one, the normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. So again, it's basically riding along like an asymptote. So remember, these four are just properties that are good to know, but you won't be required to know them. Alright, now let's talk about the means and the standard deviations. A normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line of the symmetry, and the standard deviation describes the spread of the data. So we have three normal distributions displayed below. For the first one, the mean is at 3.5, is right in the middle, and the standard deviation is 1.5. This describes the spread. For the second one, we have the same mean, 3.5, but this time the standard deviation is smaller, and you notice that the values are actually closer to the mean. So remember, the larger the standard deviation, the more the spread. The smaller, the more inward it is. And then we have the third one as a mean of 1.5 and the standard deviation of 0.7. So this is just like the second one. The third and the second ones are the same when it comes to standard deviation. But notice that their mean is different, therefore the location has moved. Alright, so now the standard normal distribution. So we know we have a normal distribution, and then we can also have a standard normal distribution. So a standard normal is just a normal distribution with a mean of 0 and a standard deviation of 1. Let me go back a second. Remember, a normal distribution can have any mean and any positive standard deviation. And of course, the three examples show that. However, a standard normal will have a mean of 0 and a standard deviation of 1. Recall that we can transform any x value into a z-score by using the following formula. It's the x value minus the mean divided by the standard deviation. This is from what we had before, so we'll still be using this. Now here are some properties of the standard normal distribution. I'll let you read through them. If you have any questions, just email me and we can talk about it. This is just more information for you to know, not actually required to know. It'll come out as you're doing the work. Okay, so now finding the area under the standard curve. Again, I will not read through these steps because this is how we would do it if we were calculating by hand. Since we're using a calculator, I'm going to bypass these steps. You should still read through them. If you have any questions, email me. And instead, let's look at the calculator steps. So step 1, you want to get inside your distribution window. So in order to do that, remember, it's the second VARS or VARS. Scroll this time to normal CDF. Before we were using a binomial CDF. So pay particular attention to the beginning of the word. It's normal CDF, not binomial CDF. And then hit enter. This should either take you to the home screen where they're going to open your normal CDF with a parentheses like below, or it'll take you to another screen and it's going to ask you for the lower and upper limit. As we do problems, we'll practice what the lower and upper limit mean. So remember, these are your calculator steps. For the most part, they're straightforward. If you get confused, again, just email me and we can work it out together. So now let's go on our books to page 243, and we're going to start by looking at number 17. And it says, find the area of the indicated region under the standard normal curve. If convenient, use technology to find the area. So number 17. And we have a bell curve. So let me draw it. So we have a bell curve, and we have 0 in the middle, and then we have negative 1.3, and it's shaded to the left. And we need to find the area of the shaded piece. So to do that, we're going to use our calculators. So find the area. We're going to use our calculators, and we're going to go to the normal CDF. And we're going to type in the lower limit and the upper limit. So think of this as a number line, because that's what it is. What is the lower limit? Who's all the way over here to the left? We need a big number. So if I go back to the calculator step, I had some notes at the bottom. For the upper limit, if it's not given, use 10,000. For the lower limit, if it's not given, use negative 10,000. So for ours, we need a lower limit, but we don't have one because this goes on forever. So we're going to use the value of negative 10,000. So we'll put negative 10,000 in for the lower. And then for the upper, well, it runs all the way into negative 1.3. So this should be your command for your calculator. So now let's do that. So in our calculators, we're going to go to the second VARS. So remember, here's your second key, and then VARS. This takes you into your distribution. Once you're in there, the second option should say normal CDF. We will never use normal PDF. It has to be CDF. So go ahead and hit enter. Now, if it takes you to the home screen, it's going to open up a parentheses, and you need to type in there negative 10,000, comma, negative 1.3. If it takes you to another screen and asks you for the lower limit, we'll just type negative 10,000, hit enter. It's going to ask you for the upper, so you type negative 1.3. This is a standard normal. How do I know that? Because if I go back to the instructions in the book, it says find the area of the indicated region under the standard normal curve. Therefore, it has a mean of 0 and a standard deviation of 1. You can hit paste, and you should have got an answer of 0.097. So the area, or the shaded piece right here, is 0.097. Alright, let's look at number 21. So same type of problem. I have a bell shape, so let me try to draw it again. And I have 0, and then I have negative 2.25. And we're going to shade in the middle. Okay, so now I need to find the area of the shaded piece. So again, I know it's my normal CDF. But this time the lower limit is actually given to me. Is negative 2.5 or 2.25. And then the upper limit is 0. So again, following the same instructions as number 17, let's get inside the second VRS or VARS. Go to your normal CDF. Type in your lower limit and type in your upper limit. And you should come out with 0.4878. So we have 0.4878, or you can say 0.488. And that's the area of the shaded piece. So number 23. Now the instructions still say find the indicated area under the standard normal curve. If convenient, use technology to help find the area. And it says to the left of z equals 0.08. So this is the same type of problem as 17 and 21, except for instead of giving me a bell curve, they wrote it as a sentence. So I can think of it like a bell curve though. So if I had a bell curve, I know that 0.08 is on it, right? And I have a line. And then they tell me to the left, so I'm shading everything to the left of it. Therefore, the lower limit is negative 10,000 and the upper is 0.08. So you're still going to your normal CDF. And it's going to be negative 10,000, that's your lower limit. And then the upper is 0.08. So let's type it into our calculators, get into your command for your normal CDF, and then fill in your lower limit and fill in your upper limit. And we should get 0.5319. And that's the area of the shaded piece. Alright, number 27, it says to the right, so now I want to go to the right of it, and then it's to the right of negative 0.65. So I have z equals negative 0.65. So this time I'm going to the right, so again let me try to draw my bell curve. I know I have a negative 0.65 on it. And there's my line, straight down. And it says to the right, so I'm going to shade everything to the right. So this time the negative 0.65, that's the lower limit. And the upper limit, well, that's going to have to be 10,000. Remember, it's not given to us, so we picked the largest number we can think of, and that is 10,000. So as normal CDF, the lower is 0.65, and the upper is positive 10,000. Go ahead and get into the command for your normal CDF, fill in the lower and the upper, and you should get 0.7422. Alright, the number 31. It says between z equals 0 and z equals 2.86. So between z equals 0 and z equals 2.86. So again, we're going to start by drawing the bell curve. Remember, your bell curve is just a number line, so these values go on it like a number line. 0 could be here, which means 2.86 is somewhere on the right side of it. I'm going to draw a line straight up and draw a line straight up. It said between, so this time I'm shading in the middle. So now I'm going to do my normal CDF. The lower limit is 0 and the upper limit is 2.86. So again, let's get inside the command for our normal CDF. The lower limit is 0 and the upper is 2.86. Type it in and we should get 0.4979. Okay, so those are problems 17 through 31. They're asking you to find the indicated area. Either they give you the bell curve like in 17 and 21, or they give it to you as a sentence, but it still means the same as your bell curve. Let's move on. Now we're going to flip over on page 244, We're going to start by looking at number 39. This is our word problem. So let me read it. The instructions say find the z-score that corresponds to each value and determine whether any of the values are unusual. In 39, it says the SAT is an exam used by colleges and universities to evaluate undergraduate applicants. The test scores are normally distributive. In a recent year, the mean test score was 1,498 or 1498, and the standard deviation was 316. The test scores of 4 students selected at random are 1920, 1240, 2200, and 1390. In part A, they wanted you to find the z-scores for each one of your x values. So let's start by writing out the information they gave us. So first we know that the mean score was 1498, and we know the standard deviation was 316, and this is part A, and they gave me they selected 4 students. That means I have 4 random variables, so x is going to be 1920, 1240, 2200, and 1390. So one at a time we're going to use the formula, and we're going to transform these to a z-score. So remember, z is going to be equal to, so x minus the mean over the standard deviation. Let's start with the first one. So z equals 1920 minus 1498, all divided by 316. So let's type it into our calculators, or you can do it by hand. So 1920 minus 1498, all divided by 316, and we get 1.34. So with your z-scores, round to 2 decimal places. So this is 1.34. Now let's keep going. Let's find the z-score for the second. So 1240, that's your x value, minus 1498, all divided by 316. Same process as before, and you should get a negative 0.82. And then for the third, we have 2200 minus 1498 all over 316. This one should give us 2.22. And then for the fourth, we have z equals 1390 minus 1498 all over 316. And we should get negative 0.34. Okay, so remember the z-score can be, an x value can be transformed into a z-score using the following formula. And then it says in part B, determine whether any of these values are unusual. So recall that a z-score, that means that tells you how many standard deviations you are from the mean. So this is the number of standard deviations from the mean. And remember, unusual was if I was 2 or more standard deviations away. So who's 2 or more? 2.22. So therefore, an SAT score of 2200 is unusual. Alright, let's look at number 41. And for 41 it says find the probability of z occurring in the indicated region of the standard normal distribution. If convenient, use technology to find the probability. So this was just like the other problems, except for now they used the word probability. However, probability means the same as area. So if you know how to find the area, you know how to find the probability. So 41, again, I have a bell curve. On my bell curve, I have the 1.96, and it's shaded all the way to the left. So to find the probability is the same as finding the area. So we're going to go ahead and go to our normal CDF. We want the lower limit, which is the negative 10,000, because it goes all the way to the left, and the upper is the 1.96. Go to the normal CDF command in our calculators through the second VRS or VARS. Type in the lower and type in the upper, and you should get 0.9750. And that's the same as the probability or the area. They all mean the same thing. Alright, number 45. Again, I have a bell shape. This time is a between, just like before. I'm still looking for probability, but that means the same as area. So I have negative 1, and I have 1. It's shaded in the middle. And we're going to go ahead and find or get into our normal CDF command. So normal CDF. This time the lower limit's negative 1, and the upper limit is positive 1. And you should get an answer of 0.6827 or 0.6826. Okay, so again, probability means the same as area. If it says find the area or if it says find the probability, make sure you're using the normal CDF command from the calculator. Alright, and then two more to do. Number 50 and then number 53. For number 50, it says find the indicated probability using the standard normal distribution. And this time they write it out with the actual probability notation. So the probability, that's what P stands for, that Z is greater than negative 1.85. Well, to do this, the first thing we're going to do is go ahead and go to our normal CDF. So we have our normal CDF. We need our lower limit. Well, it says Z is greater than negative 1.5. So the smallest, or the far left, will be the negative 1.85. And since it's greater, it's going all the way to 10,000. If you need to, you can draw a bell curve. Here's your negative 1.85. Draw my line straight up. And it said Z was greater than, so I would shade everything to the right. So the lower is the negative 1.85 and the upper is the 10,000. Type this into our calculators and we should get 0.9678. 0.9678. And then last one, number 53. It says the probability, and this time I have a between, so I have negative 1.65 and I have positive 1.65. Remember, when we see the notation like this means between. So Z is in between negative 1.65 and positive 1.65. And again, we're looking for we're looking for probability, which means the same as area. So go to the normal CDF command. The lower is negative 1.65 and the upper is positive 1.65. Type this into our calculators. So second VARS, your lower and then your upper. And you should get 0.9011. You can get 0.901 or 0.9011. Alright, so here's a summary of what we covered. We interpreted graphs of normal distributions. We've learned a few properties about the normal distribution along with the standard normal distribution, and then we found the areas and the probabilities under the standard normal curve. If you have any questions about 5.1, please email me and I'll gladly help you.